Hello everyone, I welcome you to my YouTube channel. Myself, Parikshit Godadiar, studying in Venkateswara College of Engineering, Bangalore, Department of Electronics and Communication Engineering. My version is 1VE23C068, subject Mathematics for Triple Stream, subject code BMATE201, topic Application of Rotation in Linear Transformers. Introduction to rotation in vector and linear transmission. Rotation is a fundamental operation in vector mathematics and linear algebra with a wide range application in computer graphics, robotics, and scientific modeling. Understanding the representation and properties of rotation is essential for working with 2D and 3D data and transformations. Representation of rotation in 2D and 3D spaces. Rotation in 2D spaces can be represented as a single angle, while rotation in 3D space required a combination of three angles. To fully describe the orientation, the visual representation of this rotation is often dependent to the use of coordinate system and transmission materials. Rotation materials and their properties. Rotation materials are orthogonal materials that represent rotation in 2D and 3D spaces. These materials have the property of presenting length and angle of vector under rotation. Rotation materials are invertible and their inverse is equal to their transpose. Composing multiple rotation materials results in other rotation material matrix, allowing for complex rotation transformations. Rotation materials can be used of efficiency computer and rotation coordinates of points or vectors in a given coordinate system. Rotation to vector. Rotating a vector in 2D. Multiply a 2D vector by 2 into 2 rotation matrix to rotate it under the original by the specific angle. Rotate a vector in 3D. Use a 3 into 3 matrix to rotate a 3D vector around any of their coordinate axis or an arbitrary axis. Rotate a vector group. Apply a rotation matrix to an entire set of vectors to uniformly vector field or point cloud. Composition of rotation. Combining rotation matrix can be multiplied to compose multiple rotation to a single combined transformations. Order matrix, the order in which rotation are applied in important as rotating matrix do not generate completely. Rotation groups. Combining rotation around a different axis in 3D space for mathematical groups which have interesting algebraic properties and application in physical and geometry. Particle applications. Composite rotation is circular in computer graphics, robotics, and aerospace engineering, where computer movement or algorithm need to be represented and controlled. Rotation and orthogonal matrix. Representation of length. Rotation matrix are orthogonal representation of length of vector. Representation of angle. Rotation of matrix represent the angle between the vectors. Invertible. Rotation matrices are invertible with the inverse equal to the transformers dependent of one. The determinant of rotation matrix is always included a pure rotation. Values and eigenvectors. Rotation matrices have a deep conversation with the eigenvectors and eigenvalues, which are fundamental concepts in linear algebra. Eigenvectors of a rotation matrix describes the direction that remains unchanging under the rotation, while the composing eigenvalues indicate the scaling factors along those directions. Understanding the relationship with circular for analyzing the behavior of rotation transformation and their effects on the vector space. Rotation inverse in linear transformation. Processing of rotation linear transformation can be designed into a rotation inversion, meaning they represent the orientation of vector under the rotation. Symmetric and inversion. Rotation inversion is closely linked to the symmetry properties of the linear transformer, often exposed to the group theory. Rotation equivalent transformers. Some linear transformers are rotation equivalent. Their output is also rotated is describable maybe when the input is rotated. Application in computer vision. Rotation inverse feature and transformer are closer in computer vision, those like object recording to be imagine classifications. Application of rotation in computer graphics and robotics, 3D modeling and animation, robotic control and kinematics, agreement and virtual reality, computer vision and object recognition. Rotating is essential for creating an alignment 3D models, allowing for the precision projection and orientation of the object and characteristics vertical environment. Rotation matrices are used to describe the orientation and movement of robotic limbs and end effects, enabling the computer movement and the precise control. Challenges and considered in the implementing rotation. Implementing rotation accurately and efficiency process several challenges. Numerical special sanding the game back and meaningful rotation assuming are the key consideration when the working with a rotation is computer graphics, robotics, and the other field required in the process better transformation addiction to the composition of implementing and rotation of the complex require the careful handling to maintain costly and avoid. Thank you for watching my video. Please like, share, and subscribe.